Okay, hello. My name is Warski. I work at Software Mill and with Mikołaj and Magda. I come from Warsaw, Poland. I've been in Poland for the last year non-stop, as probably most of you have been at your homes. So thank you very much for coming. I have the Q&A window open. That's why I'm looking at the side. So if you would have any questions, please ask. You can ask either throughout the presentation or when we are done. If I don't notice a question, please let me know, Shannon or El. So yeah, I guess we can start. So as Mikołaj mentioned, I would like to talk a bit about context functions, which is a new thing in Scala 3, and which is something that in fact makes the Scala language more regular, something that was missing from Scala 2. So let's start. You probably all know how to write a normal function in Scala. So we can write something like a function f, which takes an integer parameter and returns a string, right? And to implement such a function, we can take an x as a parameter and return a string that just says that we got that number, right? So that's a normal, an ordinary Scala function with a single parameter. Now, a context function is a very similar thing, with the difference that the parameter is implicit. Also, the notation is a bit different. So to write down a context function, we create a function, for example, g, and now we specify the implicit parameters. So here the implicit parameter will be an int as well. However, to note that this is an implicit parameter, we use the question mark arrow, so something like this. And this question mark arrow specifies that this is a context function. So this is the type of the context function. The IDEA console is not being updated.
Yeah, we're not seeing any updates.
Okay. This happened to me once already, and it turned out that I had to update Zoom, and I just updated Zoom again because I had 5.5, not 5.6. So hopefully that's the issue.
Hopefully, yeah.
Okay, so yeah, we've been talking about context functions and how you create the type of a context function. So if you haven't seen what I was typing, the question mark arrow is how you specify that this function is a context function. So the parameter list here is implicit. So how to implement such a context function? Well, we would want, being a Scala 2 programmer, we would want to write something like this probably, right? Got sx. However, well, you can see that there's this red underlining over here, so that's incorrect. We're actually implementing these functions a bit differently. So the compiler already knows that we have an implicit int parameter, right? So we can simply use it in the implementation over here. So in the body of the function, we are in an environment where the int implicit is in scope, or the int given, rather, I should say. These are old terminology from Scala 2. So what we can do here is we can simply summon the implicit or the given that is in scope, because that's how we have defined our type. So this summon keyword is the same as implicitly in Scala 2. So that's like the basic syntax for context functions. And just as we can type our f function as function1 from an int to string, that's f, right? So this type checks correctly. In a similar way, we can type check the g function as a context function 1, right? So a context function is an object, is like any other object. We can put it in data structures, so we can create a list of context functions like this, for example, right? It's a completely ordinary Scala object. It has a different type than a function. So this context function here is different from function 1 in that this is an implicit parameter, right? And we can use these functions just as any other function. So we can write, just as we can write a print line f from f with a parameter 10, we can call the g function either providing the parameter explicitly. And what would it look in case we had more than one implicit parameter? That's what I will show in step too. So we can call function g. Well, we cannot provide a parameter explicitly like this. This is a compile time error because g is a context function, so it expects an implicit parameter. And in Scala 3, if we want to provide implicit parameters explicitly, we have to write down that we actually know what we are doing. So we have to write down the using keyword here. But we can also print line. We can say that we have an implicit, a given integer, which is 42, and we can just call g. So now this g will actually use this implicit over here. So if we run it, it will compile and it probably will print what we have asked it to print. So this worked. Okay, so how about implicit functions with multiple parameters? So here we have an example of an implicit function which takes an integer implicitly in the given scope and returns another function, another context function which takes an implicit boolean and returns a string, right? So just as you would write down a multi-stage normal Scala function, the same way you can write it with implicit parameters. And we can use this function quite ordinarily, so we can pass it as a parameter. So here we have a method which actually requires a context function of this exact shape as g, so we can just pass it around, right? And then use it. Here we are providing the parameters explicitly, but we can also, define these parameters in the given scope and just use f as before. But we can also adjust the shape if we want to. So here we have another function which requires a context function with a different shape, right? So here the Boolean parameter comes before the integer parameter. But still, luckily the compiler is smart enough to actually adjust our g function to match this shape, right? So what the compiler will do is it will create a new context function which will use the parameters in the right order, right? So it knows that it expects something that has a Boolean in the given scope and an int in the given scope and returns a string. But, and what it can use is it can use g to actually implement this functionality. So that's what the compiler will do for us. We can also do carrying and uncarrying. So for example, here we've got an example where the two parameters are in a tuple, right? So this is the uncarried version of the function. If I got it right, I can never remember which way carrying goes, but I think that way is uncarrying and this is the carried version. But anyway, that's not so important. The important thing is that, again, the compiler adjusts the shape of these multiple parameters context function for us. So we don't have to do it. And that is very convenient when we are working with them. Okay, so how can we actually use context functions? So one use case is if you have ever used akka or if you have ever used futures, you have probably seen this implicit EC execution context. Can you mix implicit and explicit params? That's a good question. Let's try it. So val_f is a function which takes an integer and returns a context function which takes a string and returns a double, let's say. That's a valid type. What about the other way around? There's valid code as well. So yes, you can. If it compiles, it works. That's usually how it is with Scala. Okay, so if you have worked with futures, you have probably seen these implicit EC execution context parameters everywhere, right? Each time you want to map over a future or flat map a future or whatever, you need to pass and thread through this execution context, and it's quite viral, and it's not really that pleasant. So context functions give us an opportunity to refactor this code a bit. So let's take this whole code that we have here, which is some implementation of some simple logic to create a new user if a user does not yet exist, right? So to create a new user, we look up the user in the database, presumably, and if the user is found, then we return false, meaning that the user hasn't been found. Otherwise, we save the user. So what we can do is we can introduce a type alias, type executable, and this executable will return a value of type t, and it will be a type alias for a context function from an execution context into the value t. So what we can do here is we can now remove this parameter list and just say that, well, now we got an compile error, right? Because the lookup user function actually requires an execution context in the implicit scope, and we have no execution context available. So what we do is we just write an executable Boolean here, right? So we return a context function which captures the requirement that the execution context is required. And in the implementation over here, because we have set it in the type, we know that an execution context will be available. And we can do the same over here. Executable. Right, and we can remove this as well. And this should all compile fine, except that we don't have Scala FNT, but we are not bothered with that. It did compile, so we are all good. So you can say that this is maybe a cosmetic change. It saves a couple of keystrokes for sure. It looks nicer, but it's not only that. This type is like a normal Scala type, which we can abstract over, right? What I said in the beginning about the language becoming more regular, before in Scala 2, we could quite easily capture the fact that we want to we want something to be a function, and you can just write down the type for something being a function, and create pass it in as a parameter or something like that. So here we can also do the same with functions which require implicit parameters. So before, the only notation available for functions with implicit parameters was the method, right? You had to write a def name and then the implicit parameter list. Now the same is also available to be written down as a function, as a context function here. So this lifts the implicits or the givens to the same level as normal functions, and in that sense makes the language more regular. Okay, so let's look at another example. So here we have, again, the same business logic, but now divided into a couple of services. So we have a user model, presumably we are looking up something in the database over here in the user model. Then we have a user service, which depends on the user model. Here, the dependency is injected using a constructor. And we have some API, which again, depends on the user service to, well, here we will probably want to expose an HTTP API or something like that. But for a demo, we are just invoking our methods, right? And what is important for our example is that the dependency, so here we have a dependency of the user service on the user model, and this dependency is hidden from the users of the service, right? So the API has no idea that the user service actually uses a user model to implement its functionality. So the dependency of user service on user model is hidden from the caller. But sometimes we want to make some dependencies explicit. So for example, here, probably we would want to run this code in a single transaction, right? We would want first to find if we are using a relational database, that is. We would want to find things in the database, and if it's not found, only then save the user, but we want to capture it in a transaction so that we don't get any nasty errors that might happen in between. So what we really want to do here is we want these methods to return transaction fragments. And this is often captured in Scala using a type constructor, such as a connection IO in Doobie or a DBIO action in Slick. So what we will do is we will introduce a trade connection, which represents an open database connection to our relational database. And we will introduce a connected type returning a value of type T, which will be a context function from a connection to type T. So again, this is similar to connection. If you know Doobie, you've got connection IO. If you know Slick, you've got DBIO action. And connection IO is something more or less similar, at least conceptually, to our connected of IO of T. A connection IO in Ruby is a description of some database operations which require an open connection to the database. And here, similarly, a value of type connected T will be a description of a fragment of a transaction which needs an open connection and yields a value of type T. So now let's use our connected type constructor over here. So what we will do is we will change the signature of our user model so that now it returns transaction fragments. So find will be a fragment of a transaction finding a user, similarly for save user. And now you can see that in our user service, we actually get errors, right? These errors we can try compiling, and we will see that these errors say that no implicit argument of type connection found, right? So again, well, what can we do? We don't have an open connection, so we have to propagate the requirement connected Boolean, right? So now we say that our new user method returns a transaction fragment, which actually is composed of two operations, and we express the fact in the type, and all these dependencies are explicitly resolved. I was talking about hidden dependencies before, user model being a hidden dependency. Here we have an explicit dependency which we propagate to the callers of our method. And indeed, our caller of the method now has an error, you can see over here, because it doesn't have an open connection. Well, here we have to provide one because that's the edge of our system. So let's create a database class. It will have a transact method, which will allow us to eliminate the connected dependency, connected T, and well, there's some implementation which actually executes these operations in a single database transaction. And we will add a dependency on our database over here. So what we have to do here is we have to write db.transact, thus in this way eliminating the dependency from our method call. Okay, so you might wonder, if we program in this style, how does this compose, and does it compose? Of course, and indeed it does. So here we have two such type constructors for managing explicit dependencies. One is something that we know, which is the connection, and the second one is a clock for expressing dependencies which depend on the current time. So let's say we have some kind of a resource that's like an entity in our system, and we have a method which touches the resource, and so it updates the timestamp of the resource in the database or something like that. And what it does is it returns a function that operates on the database, so it needs a connection to the database. It's a fragment of a transaction, but it also accesses the clock, temporal unit, right? So that's some function. I will talk about the RR comment in Zio in a second. So that's our method, and here we have two requirements that are composed. So now let's say we want to write a high-level method in a service which will update the resource somehow by touching it. So what we want to do is we want to touch the resource, and let's say we want to eliminate one of these dependencies. So let's say we just want to return a connected unit. Of course, this doesn't compile because here we don't have a clock instance. No implicit argument of type clock was found. So we have to provide one, right? Now in the type, we have specified that we only return, and we only depend on a connection. So here we have to eliminate this dependency by providing a clock instance. And this will now compile nicely. So what this shows is that these dependencies, these dependencies can be eliminated in any order, right? Here we have eliminated a dependency that was inside the connected one, right? We have eliminated something from the inside. Again, these are just context functions, so the compiler knows how to adjust it. And finally, let's look at how this might work with IOmonas, right? So here we have a very, very simple implementation of an IOmonad in Scala. It's probably not a monad, but a monad-like. It's just a lazy computation and with a flat map operation so that we can sequence two IO operations. And let's say that we have two operations. We can have two programs. We have one program which returns an IO of int and requires a clock. Well, no, not temporal, but security, right? So here I've changed the example a bit. So a secure operation requires some kind of principal, maybe a logged in user or something like this to be executed. But again, it needs to provide some context, right, for the value to be for the value t to be obtained. So here we have a secure operation which is implemented somehow. We have another program which is a transaction fragment, maybe a string. So can we use the flat map to compose these two? Let's try. So let's assign it to a result, and we will do p1.flatMap p2, right? So it's very simple sequencing of these operations. This doesn't compile, and let the compiler guide us as to why this doesn't compile. There's no principal, right? So, well, we will need to return a principal. Well, we will need to return something that needs a principal and the implicit scope. So the secure type. Well, I think the result type here will be string. So let's try that. There's still a compile time error. No implicit argument for a connection. Okay, so we need to add a connected type here, a connected requirement over here. Let's see. No, found IO of string requires string, right? So here we need an IO of string. So the compiler guided me quite nicely into the actual proper type that is returned over here, right? It cannot be inferred, but you can be guided as to what the type should actually be. And indeed, even though we have used this P2, which requires the open connection only inside the flat map, right? So you, at first sight, you might have expected something like this, IO of connected string, right? But again, if, as we have written down the type in this form, the compiler is smart enough to figure out where the implicit parameters, where the givens, sorry, should be provided. And it doesn't matter what's the order in which we write down these type constructors. So speaking of Zio, if you know Zio, Zio is an IOmonad, which also includes something reader monad component. So the reader monad is a way in which people have managed to use to compose values, to compose return values of functions when context functions were not available. So in fact, context functions in a way codify the reader monad and bake the reader monad into Scala itself, making it easier to use than it was before. And I think Zio can benefit from it as well. So in Zio, we have these three type parameters. If we have a value of type Zio, it means that it requires a value R to be evaluated, and it returns either an error or some value A. So in a way, a value of type Zio REA is something like a function from R to either E or A. And this computation can happen asynchronously and async either, right? So that's more or less what Zio is. And well, this looks quite similar to our context functions. The added benefit of the Zio environment, because that's what's called the Zio environment, is that it can be allocated in an effectful way. So if you have some kind of resource that needs allocation and release, Zio will take care of that. With context functions, you will have to do it manually. Can you combine Zio and context functions? Probably you can, but then you would get, you know, something like R context, right? Arrow R. So you will get like these two levels. So you probably should use either one or the other, not both. So yeah, so Zio and plus resource management. But I think the context functions have quite a lot of opportunity to actually replace the ZIO environment usage in many cases. Well, yeah, with the missing benefit of resource management that you have in ZIO. But if it's true, of course, we will see in practice. Okay, so that's all I had. As we have seen, context functions are a generalization of functions as values. They are mostly automatically referred by the compiler. Somehow, sometimes we have to write down the type and tell the compiler what we actually need. But the compiler is quite good in guiding us in that process. And context functions can be used to express environmental requirements. There's the Dotty docs, sorry, are quite comprehensive, so you might take a look. And yes, thank you very much. If you have any more questions, it's a good time now.